Very good morning. Myself, Shivraj Singh, Assistant Professor in Electronics and Communication Department, uh, Sagar Institute of Research and Technology, Bhopal. Today, I will be discuss about the sampling and its type on the subject of digital communication. Firstly, discuss about the sampling. That means what is the sampling? Basically, sampling process performed by the sampler. So sampling is a process in which we convert the continuous time signal into a discrete time signal. This is the sampling process. In sampling process, in this slide, so the here M of T, that is known as a message signal or continuous time signal or analog signal. This is the sampler. Sampler is a device which perform the sampling operation in which the convert the continuous time signal into a discrete time signal. Here the second signal is impulse train function, which nature is a periodic. If we pass through the sampler basically perform the multiplication of the message signal and carrier signal, also called the impulse train signal. After the sampling process, the resulted signal S of t represented this one. That means we multiply the message signal and impulse train signal. The resultant signal known as a sampled signal, which is obtained by the multiplication of message signal and impulse train function. The amplitude of the impulse train function or sampled signal achieved from the message signal amplitude. That means sampled amplitude uh, is equivalent to the amplitude of the message signal at the particular point. Then sampled signal is the discrete time representation of the original message signal. That means here the each at every point the amplitude of the sampled signal represent the original message signal. The again sampling process satisfied the first one. Sampled signal should be represented the original signal faithfully. Second point, we should be able to reconstruct the original signal from the its sampled version. That means if we want to convert the continuous time signal into discrete time signal, at the receiving end, again we reconstruct or recover the original message signal from the sampled signal. So for this purpose, a condition that is called Nyquist rate या Nyquist criteria. In this figure, so this one the continuous time signal, this one the impulse train function, and in the third one the sampled signal. In case of sampling frequency increase, then the sampling time period or decrease due to time period sampling time period inversely proportional to the mass sampling frequency. Again, in this figure represent shown in the red color, this is the continuous time signal. This one the impulse train function. That means sampling time increase, then frequency decrease. Next one, the sampling theorem. If we convert the continuous time signal into a discrete side signal, or again, we reconstruct the original message signal from sampled signal, so it is compulsory. It is compulsory required to the sampling frequency must be equal to or greater than 2 times of the FM. FM represents the maximum frequency component of the message signal or analog signal. For this purpose, we study about the sampling theorem. According to sampling theorem, a continuous time signal can be completely represented in its sampled from and recover back, that means reconstruct again from the sample from if sampling frequency f is greater than or equal to twice of the maximum frequency of the continuous time signal. That means if we perform the sampling process, that means it satisfies the sampling theorem. That means in this figure, so that this one the continuous time signal. This continuous time signal is converted into the discrete time signal with the help of sampling process that is called sampler. Again, we reconstruct or recover back the original message signal from sample signal. It is the condition in which the original message signal recover, that is sampling frequency greater than equal to 2 times of FM. Next one, sampling rate. Sampling rate defined by the number of sample per second or per unit of time. That means how many sample take place in the particular time period, that is called sampling rate. Next one, the Nyquist rate. Nyquist rate is defined by it is the minimum sampling rate. That means omega s equal to 2 times of omega n, or sampling frequency omega s equal to 2 times of fm required to recover the original message signal, that is called Nyquist rate. Nyquist rate, that means how can recover the original message signal from the sample signal. That means it is compulsory required to fs equal to 2 times of the maximum frequency component of the message signal. That means Nyquist rate या Nyquist interval Ts equal to 1 upon Fs. Fs represent the sampling frequency, or sampling frequency equal to 2 times of Fm. That means sampling interval or sampling period equal to Ts equal to 1 upon 2 times of Fm. Next, we'll discuss the type of sampling. There are two types of sampling: ideal sampling and practical sampling. Practical sampling also divided in two parts: natural sampling and flat top sampling. Firstly, discuss about the ideal sampling. In the ideal sampling, we can use the impulse train function as a sampling function in the sampling process. So basically, ideal sampling performed by the multiplication of the original message signal into impulse train signal. This sample signal is obtained by the multiplication of x of t, that means original message signal, and the impulse train function, that is delta t. Duration of the each impulse is extremely very short. That means in this figure show that the impulse train function width is very narrow. In this case, sampling rate is infinite. That means large bandwidth are required to transmit the signal. The disadvantage of ideal sampling is the first one, due to very narrow sample, transmit power is very small. Signal to noise ratio is low. That means if the signal power is reduced and noise power is high, then overall SNR, that is called signal to noise ratio, is low. The sampled pulse may be get lost in the background noise. Second one, there is no ideal filter available to cut off the signal. These are the basic disadvantage of the ideal sampling. To reduce this drawback or disadvantage, we can improve by using practical sampling. Practical sampling, there are two types: natural sampling and flat top sampling. So firstly, discuss about the natural sampling. In this sampling pulse have the duration of tau and separated by the sampling time period of Ts. So here in this figure, we can show that this is the our message signal. This is the our carrier signal, that is called sampling signal. In this signal, we can assume the pulse train with the finite duration tau. The sample signal is obtained by the simply multiplication of the message signal and impulse train function or sampling signal. In this case, the resultant sampling signal, the top of the sampled signal follow the original message signal. That means pulse do not have flat top, but their top follow the waveform of the original message signal x of t. The basic advantage or merit of the natural sampling is generation of natural sampling is very easy. Practical low pass filter can be available or used. Basically, there are two disadvantages. Amplitude of sampled pulse is varying due to the original message signal are varying. For large value of tau, crosstalk was introduced. This disadvantage can be reduced with the help of flat top sampling. In flat top sampling, based on the principle of sampled and hold circuit, the amplitude of the sampled signal are constant. That means if we multiply the message signal or pulse train function, that is sampling signal, the output of the sampled signal for has the topmost part flat. Flat are available here due to in the flat top sampling we can use the sampled and hold circuit. That means it is sampled and particular time duration is hold. So here the sampled signal, the topmost part is flat, and the merit of the flat top sampling is better signal to noise ratio due to finite duration width of the impulse trace function. That means signal strength or increase or noise are reduced. That means better signal to noise ratio achieved. Generation of flat top sampling is easily, and practical filter can be used to reconstruct the original message signal. The demerit of the flat top sampling, if we reconstruct the original message signal due to flat top of the topmost of the signal, the higher frequency component loss. This loss is called aperture effect, and this aperture effect can be reduced by using pulse width or decrease. If in this diagram, if pulse width are reduced, then the aperture effect are also reduced. This is the overall the sampling and its type. Thank you.